Hi folks! Today I'd like to take a look at a long-term engineering project that my 8th grade physical science students took on. In this activity, students had to build a device to sort a heterogeneous mixture consisting of marbles, coins, beads, and dice. But the most difficult part of the challenge was that the entire mechanism had to fit within a cereal box. Now, I've been teaching 8th grade for a while now, and I've always enjoyed trying new activities. But it's been a while since I've been this excited about a new project. Not only did my students build devices to tackle the problem, but they also helped design the expectations and rules and created the grading criteria for this project. So let's sort through everything that went into making this project happen, from the planning and design phases through the prototyping, testing, and refining. We'll also look at how 3D printing played a key role in many of the designs. Let's get started. This activity came about as a way to meet some of our new engineering and design solution standards, while also wrapping up a chapter on properties of matter. The idea actually came from one of the AI teaching tools I use. I told my students about a month ahead of time to bring in cereal boxes for this activity. I also got help from my kids and our teaching staff to help gather extra materials. I told my students that there wasn't a size requirement for the cereal boxes, but that bigger boxes would give them more room to work with. That being said, some of the most creative and successful designs ended up using smaller cereal boxes, so it's really not that big a deal. I had some trouble finding resources for this activity. After all, it was an idea suggested by AI. There were a few images of STEM sorting challenges, but nothing that really explained the process or provided good examples for students to look at. So I had to make most of it up as I went. I did find and print a coin sorter model from Printables, which gave me a starting point, but the rest we had to make from scratch. First, we had to figure out the rules for this activity and what we'd actually be sorting. I let my students help decide this. One class period chose the materials, and my other classes chose things such as the scoring criteria and rules for the sorting device itself. We eventually settled on marbles, beads, coins, and dice. I like this combo because the objects are so different and present unique challenges for sorting. Once we figured out the materials, I measured each object and shared the recommended dimensions with students, in case they wanted to design and 3D print their own filters. I even printed some sample filters to give them an idea of what might work and what wouldn't. At the same time, I started building my own prototype. I've never done this activity before, but I've sorted my fair share of Legos, so I figured it would involve a series of reducing filters. The real challenge, though, turned out to be sorting the coins. That part required some creative problem solving, but I eventually figured it out. Well, kind of.
Not good. Well, we can get rid of all of this.
Now, before we get into the sorting, I want to take a moment and have an aside with you, because this project led me to do some soul searching. After letting students come up with the criteria for the project, I had serious doubts that it could actually be done, and I was worried that I was setting them up for failure. Sure, I built my own prototype, but its success was marginal to say the least. But what I love about engineering is that even simple problems can have an infinite number of solutions. And I'm willing to admit that I don't always have the right solutions. So sometimes we just have to be honest with ourselves. There are a lot of bright minds out there who can probably figure it out. So now let's take a look at some of their solutions. About half of the groups ended up 3D printing some kind of sorting component. Even the groups that didn't print filters got creative. They found a use for the scrap rafts that I've been saving from past prints. Those pieces turned out to be super handy, since they're firm but flexible. Every group approached the challenge a little differently, which was awesome to see. Some groups used a series of single filters, starting with the largest objects like dice and coins, then moving on to marbles and finally the beads. Others went for multitasking, creating filters that could separate two objects at once. What made this activity a bit more flexible was that students could decide where each object would end up. All they had to do was explain their plan to me before testing. Some designs sorted items by layers, while others used separate components to catch the objects. Many groups had one type of object drop all the way down to the bottom of the box, while others divided the space horizontally using compartments I've 3D printed for them. I was very impressed with their creativity. While some of the designs had some similarities, every group came up with something unique. After 5 Fridays of building, testing, and redesigning, the big day finally arrived. I reminded students of the stakes. Their designs would be graded on how well they worked, and I hinted that there would be chances for redemption if they didn't. The rules for testing were pretty simple. Students had 1 minute to pour the objects into their device and sort them before the box had to be opened for scoring. They could control how fast they poured and could tilt, shake, or sift the box. Anything except directly touching the objects that they were sorting. If a piece fell out of the box during the test, they could put it back in, but they weren't allowed to use their hands. While some students were nervous about how their devices would perform and how they'd be graded, I assured them that all would be fine. You'll see why in a moment. So what about the groups that didn't succeed? Well, part of the engineering and design process is evaluating failures. So the less successful their device was, the more evaluation students needed to do to figure out what went wrong. The more scoring targets a group missed, the deeper they had to dive into their design flaws. But as long as the group answered all the questions, they would earn all their points back. I'm still deciding on what I'm going to do with this activity next year. I might simplify the categories by sticking to an even 50 items, or maybe I'll shake things up and let students choose their own items to sort. Another idea is to create a list of about 15 items and have them vote on which 4 they want to use, something to mix it up and keep it fresh. But even if I don't change anything, I think this was still a big win, and I would highly recommend trying this activity at any grade level. In the next few videos, we're going to take a look at how we used a 3D printed modular car to investigate each of Newton's 3 laws of motion, and how we can modify this car to conduct investigations on wind-powered vehicles and mousetrap cars. Hope you enjoy the ride. Don't forget to like and subscribe.